Welcome back. Today we're looking at classes of matter in this segment. Now you're probably going to be viewing this program if you're one of my students in the autumn, and isn't it wonderful when you get out into God's creation, all the beautiful things that we can see. And as you look around, maybe even traipsing up a brook in a mountain stream or not far from where you live, there's all kinds of materials that you run across. And it leads you to ask the question, well, what are the different kinds of materials that God made when He spoke into the world? I want you to remember and think about the fact that God's got a positive attitude about the world that He has made. The earth is the Lord's and the fullness thereof. So He's got a positive attitude about the world that He's made, and we need to share that same value as well. When you think about it, when Adam and Eve were created and placed into the garden, they were given a stewardship over the world to provide for their own needs using the things that God had given them for His glory. And so we have this stewardship that we've been given by our Heavenly Father. So we want to get a handle on what are the different kinds of materials that we find in the world. And of course, it's going to start off with this concept of matter that you see in the middle of the screen. Well, what is matter? Well, it's anything that has mass and volume. It's going to be in various states of matter, as you can see, things that are solid, that are liquid, that are gas, even plasma, which is what the sun is made of, which is an energized gas that emits light. But when you look at the different kinds of matter that are in the world, they basically fall into these two categories. If you're walking about, the woods, you're going to see things are just not, set in jars out in the world. They're all mixed together, and it makes you think of mixtures. But there are also pure substances that we can get from those mixtures. So let's concentrate then for a moment on mixtures. And as you can see, there are two or more materials that are physically combined, and yet we can separate them by differences in their physical properties. When I say a physical property, I'm saying characteristics that a particular material has that are specific to that material. It's going to be color, it's going to be the size of the material, crystal size, melting point, boiling point, and the list certainly goes on. So we're going to take a look at physical properties and take advantage of how we can use them to separate mixtures. I'm going to focus on three in this program. So the separation of mixtures may involve breaking those mixtures down by differences in particle size, or by differences in the temperature at which that substance boils or melts as well. And we could exploit those differences to separate mixtures. Also, solubility. Not everything dissolves in different kinds of solvents in exactly the same way. And so we want to take those differences into account as we seek to separate those. I'm only going to give an overview of these processes here in this video, and there's plenty of other programs that you can see on YouTube and elsewhere that'll show you exactly how they occur. First off, differences in particle size. So if you have different particle size materials, they can be separated by a screen, a sieve, a grate, a filter, very easily. Solids being mixed in with other solids, solids being mixed in with other liquids, which we call a suspension. Materials that are going to settle out and can therefore over a period of time they can settle down and then you can draw off by means of a siphon the liquid part of that mixture, which we call decanting. And that works very well. We also want to take a look at differences in boiling point and melting point. And just briefly here, distillation is how we separate out products of crude oil, such as gasoline, kerosene, aircraft fuel, and many other products besides. Crystallization is a favorite for people that are in the pharmaceutical industry because we can purify chemicals to a high degree using crystallization, because it's only going to be those molecules that are similar that are going to attach and grow onto that crystal. So we find it very useful in the making of different kinds of pharmaceutical products. And then we move on to solubility differences. There are materials that will both dissolve into the same substance, such as sugar and citric acid. They will dissolve very easily into water, and only one of them is going to dissolve into alcohol. Citric acid dissolves very well into alcohol, and yet sugar doesn't. So we can take advantage of that difference to separate those kinds of materials. Now, there are different types of mixtures as well. When we think of suspensions, we're thinking normally of a solid material of a fairly large particle size that's added to a liquid, and over time those particles tend to settle out. So think of things that you need to shake up before you use them, like chocolate milk or certain salad dressings. Certain medicines that you see here, for example, are going to have to be shaken up before you use them. Those are all great examples of suspensions, and of course blood is as well. We can separate out the liquid portion of blood from the different types of blood cells that are in there. It's a very useful technique. So that's what a suspension is. It's one type of mixture. And then a very important class of mixtures that we're going to spend a bit of time later on this year are solutions. And that's a mixture in which one substance of the smaller quantity, which we refer to as a solute, is going to be mixed or dissolved into, combined with, another substance of a larger quantity, which we refer to as a solvent. Tap water, for example, as you see here, it's not pure water coming out of that tap. Neither is ocean water. There are different kinds of minerals and gases that are dissolved into tap water and to ocean water. Soft drinks, coffee, vinegar, tears. Think of the taste of your tears. They don't just taste like water, do they? No. There's other things that are dissolved into our tears in addition to the salt that you taste. There are also solid solutions, such as metal alloys, when you think of the fillings in your teeth. If you've ever gotten a filling placed into one of your teeth, that would be a great example of that. Air itself is a solution of oxygen mixed in with nitrogen along with some other gases. So those are just some examples of solutions. It's another type of mixture. And then as we move on, we want to not forget about the fact that there are also pure substances. These are materials that, once you've separated out a mixture and you've done a variety of different physical separation techniques, and you're going to run across materials that they just don't separate into anything else after a while. We refer to those as pure substances. The last time you went and bought sugar at the grocery market, if you pick up that packet, it's going to say pure cane sugar. If you buy Ivory soap or some other brands of soap, it's going to say 99.99% pure. It's almost pure. These are things which can't be broken down into simpler substances by some physical means. And as you can see, there are basically two categories of these. They are compounds and elements. Well, what do we mean by a compound? Well, compounds are made up of more than one kind of atom that are chemically combined and done so in a very specific ratio. For example, water, salt, table sugar, alcohol, carbon dioxide. These all are going to have a specific ratio at which they combine. In this case, as you see, water here, it's going to combine in a ratio of 2 hydrogen atoms for every oxygen atom. And we even build models of those things, as you see pictured here. Another example, of course, is going to be table sugar. You can see the structural formula present here. There's actually 2 rings of smaller sugars that are chemically combined right across this bridge. And they're going to have their own chemical formula. There's many different types of sugars. They have very specific chemical formulas and structures that you see pictured here. So that's what compounds are. They're made of 2 or more different kinds of atoms that are chemically combined. And when you take a look at this diagram, these gray cylinders that you see joining the different colored balls, they're going to represent a chemical bond which forms a stable attachment between those atoms. Now, why that happens and how that happens, we're going to save that for a future segment. All right, so that's what compounds are. Now, what are compounds made of? They're made of different kinds of atoms, which we refer to here as elements. These are substances that consist of only one kind of particle, one kind of atom. Examples that you're probably familiar with as well are hydrogen, helium, which are the two most common elements in the universe, followed by oxygen, carbon, iron, silver, chlorine, uranium, and of course the periodic table, which you see pictured here, is where all the elements are that we're aware of now, and the list seems to keep growing. Year by year, you're looking at 118 unique different kinds of particles of which all the matter in the universe is made. Some of these are much more common, some of these are relatively rare. And we're going to look in detail about at atoms and the periodic table in the not too distant future. All right, so what we accomplished today was just to take a look at the structure of matter and the different kinds of matter that we see, mixtures and pure substances. Well, listen, our time is up. Thanks for watching. Hit the like button underneath this video if you found it to be helpful. And this is Tim Zietz once again from Linville Christian School. Thanks for watching. Bye-bye.